Okay, good afternoon. Good day class. Okay, so additional ano lang to, additional material lang para sa inyong last exam. So gusto ko lang kasi ng closure, no? Pwede niyo naman to basahin on your own. Pero ayan, maganda kasi na may closure yung ba't ba natin inaral tong relativity sa electrodynamics. Okay, so tuloy tayo. Um, Okay, relativity pa rin ang topic natin, but this time let's talk about mechanics on how things work, paano yung mga velocity, and etc. etc. Okay, so ngayon di-describe natin yung proper time and proper velocity. Proper. Okay, medyo misleading yung term, no? Kasi parang pag inisip mo proper, tama. Proper, parang correct. Correct, di ba? So, hindi ganun. Hindi siya tamang isipin. So, kasi ito ay galing sa translation lang ng French. Okay? So, ang ibig sabihin ng proper dito would be own. Okay? So, yung own time. Okay? So, we have tau. Let's define tau. Let's define tau to be the proper time. Proper time. Which, of course, ito yung clock mo, yung oras mo kapag gumagalaw ka with the speed u. Okay? So, speed u. Okay, bakit nagpalit na tayo ng u? Yung u kasi ay gamitin na natin yung u as yung velocity ng sarili mo. Yung v is natin siya, save natin yung v sa speed ng reference frame o reference frame. Okay, so u is yung speed mo, okay, of yourself. Alright, so ayun yung u. Okay? And then u would be defined as, syempre, yung vector na distance over time, which is dl. Ito, dl over dt. Syempre, l mo would be the path, which is a vector kung saan nakatutok. Okay? Okay. So, ayun yung dl over dt. So, yung t dito, mo ay yung normal letter na t, would be the time sa paligid mo. Okay? So, ito yung time, yung stationary reference frame, ganyan. Okay? And yung DL would be, yung L, yung pass would be the stationary na length nung dinadaanan mo. Okay? Okay. Okay. So, yung U would be, wari, isipin mo na may sinasakyan kang tren. Yung U would be, yung speed ng tren would be, of course, yung initial point, tapos yung final point, tapos, di ba, final minus initial distance, tapos, divided by kung anong oras ka umalis, tapos, anong oras ka dumating. So, x final minus x initial, di ba, ganyan yun. Tapos, time final, time initial. Okay, so ayan yung DI, yung DLDT. DI. Okay, DL yan, DL. Okay, so ito ay measured with respect to yung stationary things, di ba? Kung wari, ETA mo would be this one, tapos alam mo sa map na yung distance mo with respect to that sa pupuntahan mo. Okay, so that is XF. So yung TF mo would be ETA, tapos kung kailan ka umalis at kung saan ka umalis. Okay, everything is normal. Diba? However, parang hindi mahalaga yun, di ba? Kasi when you move, kapag nakasakay ka na, iba yung tick ng clock mo. Di ba? Kasi yung tick ng clock mo would be slower, which is defined by this. Yung proper time mo would be slower. Therefore, kapag parang mas maganda atan ay define yung velocity with respect, of course, to your proper time. So we define eta. So we define eta to be dl over dt. So, ito ay combined, no? So, yung dt, yung dtau, sorry, yung dtau would be your time, tapos yung dl would be with respect to the ground, with respect to the stationary reference frame. Okay? So, so with this, yung eta would be defined as with respect to the velocity u as this. Okay? All right. Yung u would be called ordinary velocity, and then yung eta would be proper velocity. Again, proper meaning sarili mo. Okay? So yung proper velocity mo would be, again, with respect to the ground, distance, tapos yung time with respect to your own clock. Okay? So bakit natin gusto gamitin tong proper time and proper velocity? Kasi si d tau ay invariant siya. Okay? Hindi siya nagbabago with respect to every reference frame. Nakadepende yan sa speed mo. Okay? Okay. Which is nice, di ba? Kasi dumadali yung buhay natin. Okay. So familiar naman tayo sa factor na to. Diba, gamma lang yan. Okay. And it amazingly, yung eta mo is actually a 4 vector. So magiging mahirap na siya, magiging matrix na siya. So eta mu could be defined as this. Okay. So dx mu over d tau. Okay? Alam natin x mu from last time. Therefore, yung tingnan natin yung zero na vector. So this will be eta 0. Yung x0 is ct, di ba? Kung naaalala nyo, ct siya. So dt over d tau, which is just dt over d tau, which is this. So you have this factor. Okay? So ayun. So in a formal sa formal statement natin in terms of the Lorentz transformations, kuwari meron kang reference frame na meron kang nasa reference frame S ka, and you want to go to the reference frame na S bar. Therefore, the appropriate Lorentz transformation would be this, guys. Okay? Yung S bar mo would be moving at a velocity v in the x coordinate. X bar coordinate. Okay? So, yung 2 and 3 mo, walang mangyayari dun. Kasi, nawala dun yung motion. Okay? So, yung motion mo lang would be with respect to the x coordinate. So, that is yung 1 yung modified. Okay? And then, syempre, masusulat natin to into a more simpler, in a simpler manner. So, we have this 4 vector. Again, this is your Lorentz transformation matrix, lambda, capital lambda. And you know this. Okay? All right. Okay. Bakit, again, tingnan natin kung bakit gusto natin itong proper velocity. No? Pag pumunta tayo sa ordinary velocity, these are the different components kapag maglilipat ka from S to S bar. Okay, so yung Lorentz transformation mo is not very intuitive, di ba? So, nakakalito siya. Kasi kailangan mo i-transform yung T mo. Kailangan magdadilate yung T mo. So, may mga extra terms na ganun. Okay, so extra terms or extra factors kapag hindi ka gumamit ng proper time and proper velocity. Okay, so that's ayun yung rationale behind. Alright. we have that. And then of course, when you have your velocity, we can now get the momentum, which is the relativistic momentum, which is defined as P, of course, as usual, P, then M times velocity, mass times velocity. But we're now going to use the velocity as the yung proper velocity mo, which is eta, mu eta. Then eta can be written as this guy. So you have mu over the square root of 1 minus u squared over c squared. And then of course, if eta is a 4 vector, then the momentum is also a 4 vector. Ayan. 4 vector din siya. And then yung P0, so that would be M, eta 0. And then yung eta 0 mo is C over that factor. C over that square root of 1 minus u squared, c squared. Okay. So that is your P0. And if you multiply it by C, not C, this gives me MC squared 1 minus u squared c squared. Okay. So this is actually the energy of the system. So in every closed system, of course, again, from the previous physics na inaaral natin, the total energy and momentum are conserved. And yung in the same way, the total relativistic energy and momentum are also conserved in a closed system. Again, in a closed system. So kapag may external forces, hindi na magiging conserved yung mga bagay. Okay, ang amazing pa dito is pwede mong iset si U as 0. Kuwari hindi ka gumagalaw, you're stationary. And then, ano mangyayari pag ginawa mo yun? So, if you set this to 0, therefore, square root of 1, that is 1. And you'll have E is equal to mc squared. And you know this, a very famous equation. Okay, so this is the rest energy. So, kahit nakahinto ka, meron kang energy. And that is given by mc squared. Okay? Tapos, if factor out mo yan dito, if you split mo to into rest and kinetic, you can see that yung E, kinetic mo would be E minus mc squared, E minus the rest energy. And then therefore, ito yung lalabas. Okay? Ito yung kinetic energy ng system. Ito yung total energy. Alright. Okay. If we get the scalar product of the momentum with itself, syempre alam niyo to, ito yung covariant tsaka contravariant, kung nakaalala from last topic. So if we do that, ito yung normal na dot product mo with itself na spatial terms. Then again, yung first term mo, P0, would be negative. Kaya may negative sign. Okay? So yung dot product would be normal for the spatial terms. Then for the temporal term, may negative. Okay? Okay. And if we do this, di ba, isipin natin, balik tayo sa P, definition ng P. So P squared, may kakaroon ka ng U squared. Tapos, itong P naught would be, what is that? What is P naught again? Pinuha ko yun dito. Ang P naught ko would be MC. Tapos, i-squared ko to. So, MC squared. Tapos, ito MU squared. Pag pinagsama-sama mo sila, magka-cancel yung denominator and you'll be left with something like this. Negative M squared C squared. Okay? Okay, so we have that. So, kunin natin to. P naught squared. Tapos, minus P squared. Tama? P dot P is P squared. must be equal to m squared c squared. If I multiply everything by c squared, so p naught squared, p0 squared, sorry, I'm very sorry for that. P0 squared, c squared minus p squared c squared is equal to m squared c to the fourth. Okay? M squared c to the fourth. And what is this entity? This is just e squared. Diba? Kasi P0C is just energy. And then I have this guy. Okay, so this is useful kapag hindi mo alam yung velocity ng particle. Okay, hindi mo alam si U. Pero alam mo yung momentum niya, you can get the energy. Or kunyari, alam mo yung momentum niya, tapos di mo alam energy, you can get this. Okay? So, useful. Okay. Siyempre, ito ay puro math. Puro math lang to. So, punta tayo sa applications niya, yung physics. Okay? Let's go. Alright. Proceeding now with the examples sa relativistic kinematics natin. Okay, try natin to. So, two lumps of clay, each of rest mass m. Then they collide head-on at 3/5 the speed of light, and they stick together. So the question is, what is the mass m of the composite lump? Okay? So with these problems, ang gagamitin mo would be conservation of energy o di kaya momentum. Okay? So kung titingnan natin by inspection, no, hindi useful dito yung conservation of momentum kasi on the left-hand side, mag-zero siya. And then on the right-hand side, yung sa final state mo, would be zero again dahil hindi nagagalaw yung composite lump mo. Okay? So not very useful. So let's try using energy, conservation of energy. Okay? So tingnan natin yung energy ng isang particle. Energy ng isang particle would be E. Ito, papel na natin to. M C squared. Square root of 1 minus 3/5 squared. Kaka-cancel na yung mga c squared, no? So we have this. And then this is 25/25 minus 9/25. And this is obviously 5/4 mc squared. Okay? Okay, so that is the energy of one mass of one clay. Therefore, yung initial state mo would be 5/4 mc squared plus 5/4 mc squared. So walang paki yung energy sa direction mo. Okay? Kasi u squared yan. Positive lang yan lagi yung u squared. Kahit left, to the right, same lang yan. Okay, so you have your energy here, initial state. And then on the final state, the energy would be the rest mass. So mc squared lang. Dahil walang velocity, so capital mc squared. Okay? And of course, you can cancel c squared. Therefore, the mass is m is equal to 5/4 plus 5/4. So that is 10/4. 10/4 per 4 m, and this is 5/2 m. So this is around m is equal to 2.5 m. Okay? And this is actually a nice result. Kasi you would expect that the composite mass would have m plus M. M plus M would be 2M. 2M. Di ba? Kasi pag pinagsama mo lang naman to, M plus M would be 2. 2M, di ba? But it turns out that yung composite mass is actually 2.5 M. It's greater than the addition of the two masses. Okay, so saan nanggaling yung extra mass? Dahil dun sa kinetic energy nila. Okay, so na-transform yun into rest mass. Okay, it may surprise you, but yes, yung mga may init na bagay, yung may extra silang energy, they are heavier, in fact, heavier than those that are colder. Okay, so this is nice. Okay, another one. Let's try another one. So, a pion at rest decays into a muon and a neutrino. Here, guys. Okay, so before and after. So, yung pion, nag-decay siya into mu and neutrino. Mu1 and neutrino. So, let's find out yung energy of the outgoing mu1 in terms of the two masses mu and m pi. Okay? Okay, then let's assume that, that the mass of the neutrino is 0. All right, let's do that. So now wala tayong information about the velocities of these two particles, but of course, we can still use their energy and their momentum. Okay. So how do we do that? Let's first write down the before and after states. So before and then after. Okay. So before, ang energy mo would be E pi meson or pion. So you have pi. And then the okay, so after state naman ay E neutrino and then E mu1. Okay? And then for the momentum naman, 0 before and then after would be the momentum of the neutrino plus the momentum of the mu1. Okay? So you have this guys. Okay? So let's equate them dahil sila ay conserved quantity. So you have your E mu, E pi, sorry, must be equal to E mu plus E nu. Okay? We have this and then we need to find kung ano yung mga values nito using this guy. The left-hand side is easy kasi nakahinto to, so rest siya. At rest yung pion at rest, di ba? So, m pi, c squared, okay? Rest lang siya. And then, yung mu1 ko would have something like this. Square root. Using this, no? So, using this equation, square root ng p, p mu squared, c squared, and then plus m squared mu squared c to the fourth. Okay? Make sense, di ba? Make sense, make sense. And then for the neutrino, since massless siya, plug in mo yung 0 na m. So, yung right-hand side mo would be 0. And you're left with E is equal to PC. Tama? So, for the neutrino, you have P, neutrino, C. Okay? So, anong kailangan lang naman natin ay isulat yung find the energy of the outgoing mu1 in terms of the two masses, m pi and m mu. Okay? Okay. Okay. It's not very useful pala na nilipat natin to. No? We should have let it stay like that. Kasi energy pala ng mu1 yung tinatanong. Okay? Energy of the outgoing mu1. So, let's just leave it as is. So, E mu plus P nu C. Okay? Now, ang kailangan natin is P nu. We have to write it down in terms of pi and mu. Okay? To do that, tingnan natin yung mga equation for the conservation of momentum. So, 0 ang before, tapos ang after ay P mu plus P mu. So, therefore, P mu is actually negative of P mu. Okay? So, m pi c squared mu, and this is minus P mu C. Okay. Okay, kulang ng notation. So, E nu is of course this guy. Pero, di ba, siniro out natin the right-hand side. And then we're left with E squared is equal to P squared, C squared. Then I took the square root of this, and I forgot the absolute value. E is always positive. And then E is not always positive, so we have this. So we have this guy. C is always positive. So dapat ito ay absolute value, and then therefore mawawala yung negative sign. Okay? Kasi nandito sa loob yung negative pag nilipat sa baba. Dito sa mu. Okay? Okay. Okay, now we need to find P mu. So that is easy. Kunin lang natin to. So you have E squared minus m squared c to the fourth must be equal to E squared c squared, and then you take the square root, and again absolute value ng P ng mu, and then mu squared square root minus c to the fourth squared din to, and then this is C. Therefore, ito ay m pi c squared, and then a mu plus the square root of e mu squared, tapos ito minus m mu c to the fourth squared din to dapat. Okay. Algebra na lang to, no? Algebra. Ginawa mo yan, gawin na natin para tayo lost in life. Okay, so this is m pi squared c to the fourth mu squared plus e mu squared minus m mu squared c to the fourth. Okay, i-square ko lang lahat ng term. Oops, mali. Ano ba yan? Ano ba yun? So, ito ay okay. squared plus okay, wait lang. Ayaw sumulat. Mali. Okay, so from here, ang gagawin natin, lipat muna natin itong isang term para hindi magulo. Okay, so ito ay e mu must be equal to square root ng mu squared mu squared c to the fourth. Then you take the square of both sides and normal na siya. So ito ay e mu squared minus m mu squared c to the fourth. On the other side, itong left-hand side mo would be squared. Okay, tama. And then, square na to. So that is m pi to the fourth c to the eighth. Tama, di ba? Okay. And then the cross terms would be sorry. Kaya pala. Hindi ko pala na nabura. Squared lang to dapat and then wala ito. So therefore, ito ay magiging squared lang din. So squared and then ito ay to the fourth. Okay, and then the cross terms would be 2 m pi c squared e mu. Okay? Okay. Therefore, this cancels out, and you are left with e mu over 2 mu pi. Cancel na yung c squared. C squared na nasa taas. And then m pi plus m mu. And then, of course, yung mga square nila. Okay, naka-square to, naka-square din. Naka-square to, naka-square din. Okay, so that is the mass of the energy of the mu1 in terms of the masses of the mu1 and the pion. Okay, so as usual, yung forces mo in work would be the same. No? So the force, of course, derivative of the momentum, provided that the momentum is defined by the proper velocity. Okay? And then the work would be, bibigay niyo sa'yo yung integral ng of f.dl, and then if you continue this, pupunta ka sa conclusion that work is just the energy final minus energy initial. The work energy theorem. Okay? Which is very, very, very useful. Okay? Sir, ba't parang mas maganda ata i-define itong dp over dt? Kasi ito ay t, no? Hindi ito tau. So parang maganda ata na i-define yung force with respect to your own time. So with your proper time. So yes, ito ay tinatawag natin Minkowski force. So this is given by K mu, and then dp over d tau. Okay? So for vector notation siya. Okay, so that is nice. Okay. Now we go back to magnetism. Let's revisit magnetism. Let's connect the relativity with relativity with of course electrodynamics, kasi parang we've gotten off course dahil sa relativity. Okay, now we now consider a let's consider a wire. Sorry. Let's consider two wires. Okay. Na very close to each other yan. Okay, and then you have your charges. You have your charges. Here. Okay, close to each other din yan, ha? Okay, let's just draw it for... and these charges are moving here. And on the other line, wait lang, ayaw mag-win ng color. Yan. On the other line, meron ka ring charges, of course. Okay? Alright. Okay. So again, these two wires are very close to each other. Okay. So, itong distance na to dapat negligible yan. Tapos, yung distance with each other is also negligible. And then this bottom charges, we call them they're positive. Okay? And then on the above, nasa yung mga red, those are negative charges. Okay? And then they move to the left and the positive charges move to the right. Okay? Okay, let's now assume that itong mga charges natin to ay very closely packed so that we can have it as a lambda, a line charge density, lambda. Okay, so line charge density lambda, and then if this line is moving to the right by a velocity v, and then of course the above na line R is also moving to the left with a velocity v. Okay? Therefore, there is a current that is lambda v due to this guy going to the right, and then plus negative lambda dahil negative yung charges na nasa taas, and it's also going to the left, so negative v. Therefore, I have 2 lambda v. Okay? So may net current ako na I, which is 2 lambda v. Okay? So the intuitive, di ba? Intuitive. Wala pa namang something new. Again, itong they are very closely packed. Okay? So para sa lang superimposed with each other. Kadikit sila. Okay? So when you look at this, anong mafe-feel mo na electric field? Okay, ano yung electric field na mararamdaman ko pag tumayo ako dito? Di ba, ang mararamdaman ko electric field would of course be dependent sa mga charges mo. And however, in this system, you have a positive charge, and then the other one, a negative charge, and they are very, very close to each other. It would seem like that these two charges pinoproduce yung electric field would be zero. Okay. As we expect. Tama, di ba? Lumayo ka dyan, you see that, wala kang mararamdaman na electric field. Tama ba? Okay? Okay. So, let's try to delete this, guys. Okay, so wala tayong mararamdaman electric field kapag tumambay tayo dito sa gilid ng system natin. Okay? However, let's consider a third charge. Third charge moving to the right with a speed u. Okay? the speed u, which is u less than v. Okay? So, mas mabagal siya kay doon sa mga line charges. Okay? Okay, ano sa pagka kasi kanina tiningnan natin sa point of view na naka ano tayo, naka steady tayo. However, kapag sumakay na tayo dito sa charge na to, pare, tayo yung charge na to, what would we see? So, isipin natin parang tayo nakasakay sa kotse, di ba? Tapos panapansin mo yung mga kasabay mo, they would appear to be moving slow. And then yung mga makakasalubong mo would appear very, very fast. Okay? So in essence, ang nangyayari is that yung mga kasabay mo, sila, yung mga charges na kasabay mo, it would appear that they are stretching. Okay? And yung mga kasalubong mo would appear very, very packed. Okay? So, ito yung charge natin. Sa reference frame na to, stationary na yung charge mo. Mali, nakaupo ka sa sakyan, di ba? Stationary na. Tapos makapanood mo yung mga nasa labas. Yung pasabay mo, mabagal, syempre. And then yung pasalubong, mabilis. Okay? Okay. So with that, syempre merong appropriate na time dilation, na length contraction, and then etc. Okay, so tingnan natin yung mga equations na mga patatagpuan natin. Okay, by the Einstein velocity addition, you would see that the yung mga positively charged particles would have V plus, and that is V minus U, 1 minus VU C squared. Okay? And then the other one, yung mga kasalubong mo, they would be faster. So V plus U, 1 plus VU C squared. Okay? Okay. So, ayan. So, ito yung mga velocities na nakikita mo, no? And then you have your, yung lambda, magbabago. Yung density nila, syempre, they would, magko-contract yung length nila, diba? Therefore, yung appropriate would be lambda plus. This would be, okay, plus, gamma plus, lambda 0. So, plus, gamma plus, and lambda naught. Tapos, yung gamma plus ay, ano lang yan, yung velocity ng current charge mo. Okay? So, this is a length contraction. But, ano tong lambda naught? Yung lambda naught would be yung density ng plus charges. Okay? Is this lambda naught the same as lambda kanina? Okay? It would appear, no, hindi. Kasi itong lambda naught would be, of course, ito yung reference frame na kung saan nakasakay ka naman dun sa itong linya. Ito. Okay? So, sa reference frame, okay, lambda sila. Pero kapag tinignan mo na sa paningin itong mga blue, it would appear na hindi. Okay? So, you have lambda naught. Therefore, si lambda naught naman ay magiging lambda and then gamma lambda. Okay? Okay. Okay. Okay, so yung lambda plus dito would be kung ano yung density na makikita ni yung sa reference frame ng gumagalaw na charge particle. Okay? So with these equations, okay, pwede mong isulat si lambda plus and lambda minus in terms of the lambda. Ito yung alam natin from the reality kung ano yung nasan tayo, nasa rest reference frame tayo. So magandang gamitin si lambda. So ayun, with algebra, and you can follow this in your book, you'd see that the lambda total would be, of course, the lambda plus and lambda minus. And by intuition, alam natin na hindi na magka-cancel out yung mga lambda. Kasi from beforehand, magka-cancel siya. Kapag tinitingnan mo siya sa rest reference frame mo, it would appear that they are equal. So therefore, yung lambda mo is 0. However, in this case, kapag sumakay ka na sa moving reference frame, hindi na ganun yung case. Okay? So alam natin from looking at this, mas packed yung negatively charged particles. Therefore, dapat mas malakas yung mararamdaman natin na negative. Okay. And it turns out that if you do the math, you'd actually end up with a negative sign lambda given by this. Okay. Okay. So given by that, this. And then therefore, the electric field would be easy. Di ba? Kaya natin ito kunin by Gauss's law. Okay? So, kaya natin gawin to by Gauss's law. E is E times 2 pi SL, di ba? Then, must be equal to lambda L over epsilon naught. Then L cancels out. Okay. So, we have this electric field that is affecting you kapag sumakay ka na dun sa charge mo. And syempre, with that electric field, meron kang force na mararamdaman. Okay? So, the force on Q, on the charge that you are riding on, would be QE. And syempre, kukombine mo lang itong dalawa. QE, tapos plug in mo si lambda, you have this equation. Okay? Okay? And then, syempre, kung may force sa'yo, dapat meron ka ring force dun sa kabila. Tama ba? Kasi force is two-body, ano yan, di ba? Two-body, lagi yung force mo. Okay? So, interaction yung force mo. So, therefore, yung force sa kabila would be this guy. Okay? So, may factor na ganito dahil sa mga previous equations natin. Okay. So, sa reference frame mo, QE, okay, usual, kung ano yung makikita mo dito. And then, kapag nilipat mo doon sa rest reference frame, you'd actually find that F is this. Okay? F is lambda B by epsilon naught C squared Q EU. Okay, and then let's try to simplify things. Alam natin yung I, 2 lambda V. So I can write that down. Minus I. Kaso, meron akong extra 2 pi. S. Epsilon C squared QU. Okay? And then, epsilon naught C squared ay pwede natin isulat as mu. Okay? Pwede natin siya isulat as mu naught. Okay, let's do that. Mu naught. Lipat ko na lang yung... hindi, sige. Mas maganda pala ito. Negative. Mu naught I 2 pi S And then this is Q, U. Actually, it's right. It's nice to do this like this. Q, U, tapos mu naught I over 2 pi s. And what is this? Mu naught I over 2 pi s. It's very familiar, di ba? Ito yung magnetic field due to a line charge. Line current, I mean, di ba? Kung may line current ka, you have a wire, you have thin wire, kunin mo yung current na nagpo-flow doon, you'd see that the magnetic field around it would be mu naught I over 2 pi s. Okay? And this equation seems familiar. This is actually Q V cross B. Kasi ito ay magnetic field, ito ay velocity. Let's write it down as V. Okay? And ito ay force, di ba? And we now see that the magnetism is actually a relativistic phenomenon. Okay, we have derived the magnetic field of a line charge without actually using electrodynamics. Okay. Galing, di ba? Amazing. So, yun yun. Due to the relative motion sa relativity, nagpo-produce ka ng magnetic field. Okay? Okay. So, I don't know kung ano yung mga isasama sa exam. Wala pa akong news sa mga questions. Dahil ang bibigay ko lang naman kasi ay sa chapter 10. However, for 11 and 12, wala pa akong idea kung ano mangyayari. So, I suggest you read chapter 12. Make yourself familiar with the upcoming equations. Okay? Baka may ibigay lang na tensor. Okay? So, may mga matrix. Baka magkaroon ng mga matrix manipulations sa exam. I feel. Okay? Pero wala namang hardcore na tensor. Okay? And sabi ni Sir Baguno, hindi na rin daw siya umabot sa electrodynamics in tensor notation. But it's nice to look at that. Okay? If you're really interested in relativity, astrophysics, this is a nice starting point. Okay, I think that's it for the additional material. And I will post, of course, your bonus prob sets para din mataas yung mga grades. Okay? Thank you and see you next time, guys.